Hello everyone. In the previous chapter, we learned about special equipment management. Now, let's move on to Chapter 10, Power and Energy Management. Section 1, Overview of Power Management. Part 1, Concept of Power Management. For machines and equipment to operate, power is essential. So, what is power equipment? Power equipment refers to all equipment and pipelines within an enterprise that are used to generate, convert, distribute, or transmit various forms of power or energy-consuming media, as well as other gases and fluids. The main purpose of power management is to ensure the normal operation of all power equipment, provide a continuous supply of power that meets production requirements, and make full use of all available energy sources. Part 2, Power Equipment Management. Since power equipment is so important, what aspects should be managed? The scope of power equipment management includes electricity, water, gas, refrigeration and air conditioning, generation, conversion, transmission, and usage. Specifically, it covers the following 7 categories. First, compressed air systems. Second, electrical systems. Third, steam systems. Fourth, water supply systems, etc. The main task of power management is to ensure the stable and continuous operation of power systems, and to supply all kinds of power required for production in an economical and efficient manner. The specific aspects include safety and reliability, as well as economic efficiency. Section 2, Operation Management of Power Equipment. Part 1, Rules and Regulations for Power Equipment Operation Management. In production, technical operations, dispatching, and daily operation management, unified command and strict implementation of power equipment regulations are essential to ensure safe, reliable, economical, and reasonable operation. The rules and regulations for enterprise power equipment include the Post-Responsibility System, Technical Operation Procedures, Safety Operation Procedures, Shift Handover System, Routine Patrol Inspection System, Regular Technical Inspection System, and Management and Assessment Methods for Operational Economic and Technical Indicators. Part 2, Power Equipment Operation and Dispatch System. To ensure coordination among various power equipment within the enterprise and maintain orderly operation, an internal operation and dispatch system must be established. This system should connect upward with external departments responsible for power supply, heating, water supply, and gas supply, and downward with each internal power station, power transmission pipeline, and key energy-consuming equipment. The specific dispatch method can be customized according to the actual situation of the enterprise. Part 3, Daily Management of Power Equipment. First, establish operating systems, technical and safety procedures, and post-responsibility systems. Second, ensure that operational parameters meet the equipment's design and production requirements, maintaining safe, reliable, energy-efficient, and environmentally friendly operation. Third, safety devices, protective components, monitoring instruments, and automation elements must be complete and functioning reliably. All valves should operate smoothly and seal tightly. All pipelines and auxiliary facilities must have clear labels, and the environment should remain clean and orderly. Part 4, Management of Power Equipment Failures and Accidents. When power equipment stops operating due to a failure, the situation must be promptly analyzed to determine the cause. It must be determined whether it is an operational error, a fault, an equipment accident, or an operational accident, and handled seriously. During accident handling, on-site investigation and analysis must be conducted to analyze the cause and responsibility, adhering to the 3 without let-ups principle. Major and serious accidents must be reported and handled in accordance with the regulations set by higher authorities. Section 3, Energy Management. Part 1, Definition and Classification of Energy. Energy refers to natural resources that, under certain conditions, can provide forms of energy such as mechanical, thermal, electrical, or chemical energy. Based on renewability, energy is categorized as primary or secondary. From the perspective of use, energy has the following characteristics. First, necessity and universality. 2, continuity. Third, exhaustibility and auxiliary nature, etc. Part 2, Energy Management. Energy management applies principles of energy science and economics to plan, organize, and regulate all stages of the energy system for cost-effective and efficient development and use. To quantify energy management efforts, we need to understand energy measurement management, which serves as an important technical foundation for enterprise energy management. Enterprises should adhere to national regulations concerning energy measurement and management. Energy measurement management mainly includes three aspects. First, define the scope and hierarchy of energy measurement. Second, create a network diagram of measurement points. Third, properly select and install measuring instruments. Part 3. Energy-saving measures for enterprises. Building a conservation-conscious society is a major national development strategy in China. So, how can enterprises implement effective technical measures? First, enhance scientific energy management practices. Second, carry out technical modification and equipment renewal with energy conservation as the core. Third, develop and apply new energy-saving technologies. We just mentioned energy-using equipment. What is it? It's a general term for all devices that convert, transmit, or use energy to perform their designated functions. The goal is to improve the energy efficiency of such equipment and achieve energy conservation and consumption reduction. A sound management system for energy-using equipment can be built by focusing on: first, establishing a comprehensive quality control system for energy-using equipment. Second, implementing operation, maintenance, and servicing procedures for energy-using equipment. Third, establishing a record management system for energy-using equipment. Part 4. Energy Conservation Monitoring. What is energy conservation monitoring? Energy conservation monitoring refers to the process of supervising, inspecting, testing, and evaluating the energy utilization status of energy-consuming units, based on national laws, regulations, and standards. China's energy conservation monitoring follows the National Standard General Principles for Energy Conservation Monitoring, GB, or T15316-2009. Scope of energy conservation monitoring. Comprehensive energy conservation monitoring should be conducted regularly for key energy-consuming units. Specific energy conservation monitoring should be conducted for key energy-using equipment. Contents of energy conservation monitoring. Technical performance and operating conditions of energy-using equipment. Configuration and operating efficiency of energy conversion, transmission, and utilization systems. Energy operation practices. Technical status of enterprise energy management. Effectiveness of energy utilization, quality of energy supply, and types of energy used. You should also understand the following key concepts. What is energy balance? Energy balance examines the relationship between the input energy, effective energy, and energy losses within a system. What is an energy audit? An energy audit is an inspection, verification, and analysis conducted by provincial authorized institutions in accordance with national relevant energy regulations and standards. It involves both the physical processes and financial performance of an enterprise's energy utilization to monitor, diagnose, and assess its energy efficiency and consumption levels, and to identify potential areas for energy savings and efficiency improvement. Finally, what is energy efficiency benchmarking? Benchmarking management, also known as best practice management or benchmark management, refers to the continuous process by which enterprises identify and study best practices from leading companies in areas such as products, services, production processes, and management models. By learning from the advanced concepts and practices of benchmark enterprises, improving its own shortcomings, and continuously enhancing its core competitiveness, an enterprise can catch up with or surpass benchmark companies and form a dynamic cycle process of sustained excellent performance. That concludes this chapter. Thank you for watching. Please complete the assigned exercises after class. That concludes the content of this chapter. Thank you for listening. Please complete the following assignments after class.